And we discussed today's presentation is all about BDD with Selenide. So the main goal or main agenda behind this talk is for everyone to understand or to come up with some better ways to write the most effective test code, which is business focused in less time and more efficient way. And that was exactly our goal at Fannie Mae a couple of years ago. And by following certain patterns in practices and also strategies and a couple of other new technological innovations, we were able to achieve our goal. And today I'm so happy to share my knowledge with all of you at this platform. So let's move ahead. And about me, I worked as a developer for almost 12 years, and I have experience in designing large-scale web applications and also designing complex test automation solutions for using Java J2E technologies. And currently, I'm working at Fannie Mae as a lead Center of Excellence team member. So my area of focus is completely on test automation right now. So what I do at my work is we basically provide solutions to different test automation patterns like web, mobile, API, and messaging systems and all. We have different tech stack at Fannie Mae, and each tech stack needs a different kinds of solution. And also coaching and mentoring teams in terms of best practices and other things is what I'm currently doing right now. So let's take a look at the agenda. So the agenda for today is we'll talk a little bit about BDD, which is a success criteria, one of the success criteria for our company. And then we'll talk a little bit about Selenium, Selenide, and how it is different from Selenium. And then we'll compare coding snippets from Selenide versus Selenium. And then we'll see what additional benefits that we are going to get out of Selenide. And then we'll talk about some of the design patterns and return on investment as well. So that's the agenda. So before we go quickly into the other slides, I would like to talk a few lines about some of the interesting statistics. So this is one that I got from McKinsey. So if you see, 45% of the IT projects are over budgeted. And if you see the topmost project failure, it's because of missing focus, lack of business focus, and lack of, followed by shifting requirements. We definitely understand that there is a communication gap between business and technology, and that is where we are seeing all these failures. So let's see how to make sure that this is not going to happen to either me or my company. Okay? And so we totally understand that there is definitely a bridge, there is a gap between the business and technology. So how to bridge that gap is one of the problems for us. So BDD helped us in creating the bridge between these two, business and technology. So what is BDD? It's a behavior-driven development, most of you might have known, but people has different perspective in BDD. Some people are talking it's a low-level BDD we are doing, and some people say we are doing high-level BDD, and there are different patterns around it. So for us, BDD is all about eliminating the communication gap. So it is developed, this is a practice that has been developed by Dan North back in the days. And it has a very specific meaning to solve a very particular problem in communication by using some language called examples. So in order to understand this better, let's have a look into one of the typical project lifecycle. So there will be typically 3 entities that are involved. There will be a business owner, and there will be a delivery team. The delivery team will be basically, they'll have these developers, test automation engineers, and manual testers, and then, of course, the code repositories. So these are the 3 entities. So whenever a business wants to develop a new requirement, or if they want to update something, they'll talk or they'll speak these requirements to the delivery team in the form of requirements. So once these requirements are received by the delivery team, they'll convert this into language that they understand, and they write the particular code which will be feedback to the system. And system has a different programming language and all. And if everything goes good, obviously we'll get that feedback back to the business. So this is a typical communication that happens in most of the projects. But if you see, there is a particular problem in this particular slide. So the communication, first of all, the communication is one way. So that means a business owner, he explains the requirements to the delivery team, and the delivery team, even though they understand the same requirement, but they might imply a different meaning to that. So in order to understand this better, so let me give you an example. So the business owner might be asking for a new requirement, like for example, in a financial project, let's consider it, he might want a new user registration system. So the delivery team might understand that he wants a registration system, but they might imply a different meaning to that. So they might imply it might be a user registration system, or it might be a system registration system, or it might be something else. So, and if you see the traditional project lifecycle where it takes almost months to years to deliver the software, it takes years to spot the problem. And the problem of having the same understanding in the business but a different meaning, implying it to a different meaning is called cost of translation. And in traditional models, it will take almost years to understand this cost of translation problem. And most of the teams are following Agile right now, and then they are able to reduce the cycle, and then now they are identifying these cost of translation in weeks versus years. So we are able to spot the problem, but how to fix the problem? So it's nothing but by adding a feedback loop between the delivery team and the business in the form of examples. So that's exactly what BDD is. So we are creating a circle of iterations between the business and the delivery by talking a language called examples that eliminates the cost of translation. So in the previous example that we discussed, so the business owner wants a registration system, and the delivery team might imply that might be a different registration system, but this time they talk in the language of example. So the delivery team might ask, so can you give me an example? Then the product owner, the business owner, he explains, okay, I want a particular user to be there in my system. When he withdraws a certain amount, the amount should be reflected in the system. So that clarifies assumptions, and then this process of communication takes within minutes versus weeks or months or years. So that's about BDD. But if you see this slide, there is still one more gap. It's between the delivery team and the code, and the feedback is never again coming back to the business. So even though the delivery team understands the requirements, but they are heavily business focused, heavily code focused. For example, once they go into the code and start implying all the things in the programming, they'll quickly forget about all the business. So how to solve this problem is by adding another feedback loop, this time with a shared language. So the business delivery team, everyone should talk in the same language. It's not practically possible, but if the business owner can talk in a little more programming language, and the delivery team can talk little bit more in the business language, this will solve. So there are a couple of other business languages that are available which will solve the problem. And there is one more practice in the community that is coming up, which is called domain-driven design. So this focuses completely on the business. So your development, your design and everything will be focused on the domain versus coding or development. So if we follow all this behavior-driven development with domain-driven design, if you follow these communication patterns throughout your project, so you will achieve a better working software. With that, you will end up writing a good software versus the software that quickly goes out of time and which is not business-focused. So we'll end up writing software that matters. And another good thing about BDD, what we observed is the delivery team now, they are not only focused on writing code, they're focused on writing, they are focused on involving in the conversations that are happening in the business as well. So with that, what advantage that it might happen is the delivery team might give some suggestions to the business as well. They're much more engaged and they're much more into the business, and the feedback and everything will end up writing a very good software. So this is all about BDD in delivering the software. So what is BDD in terms of test automation? So let's have a peek. So in a typical project, there will be like 3 amigos if you are following the business BDD. So on top of the image, there are 3 amigos. There is a product owner, developer, and a test engineer or test person. So they understand the business goals and then they convert them into features. The features use examples and they'll drive executable specifications. There will be some low-level specifications as well and executable specifications. So there are a couple of tools in the market, libraries in the market that you can use to create these executable specifications like Cucumber, JBehav, SpecFlow, and there are many other things. So the low-level specifications make sure that we are writing, the high-level specifications make sure that we are building the thing right, while the low-level specifications make sure that we are building the thing, whatever the thing that we are building, it makes sure that we are building the thing right. So that's the context of test automation in. So this slide gives you an example to understand. For example, there is a feature. So manage books in shopping cart. As a shop visitor, I want to collect books in my shopping cart so that I can purchase multiple books at once. So these are converted into executable specifications in this format. So they derive, 3 amigos derives multiple scenarios for this particular feature in this way. The scenario 1, books can be added to the shopping cart, and the given, when, then are examples of that. So given is a set of preconditions. When is when a certain action occurs, then is what is the outcome of that particular feature. So there are multiple scenarios like this. So this is a typical example. So, that is discussed as part of practices. So let's discuss about what in terms of tools that we can leverage to meet our goal, like writing test code that is business focused. In order to understand this, let's see the evolution of UI automation. Back in 1980s, we have record and play tools, HP tools, we have a couple of IBM tools and all. That were satisfied at that particular time, but later we figured out there are so many problems that are coming out of these tools, like dynamic data cannot be captured, and there are so many other things like that. So we ended up having a Selenium WebDriver, and ever since Selenium WebDriver evolved, it has become a main ingredient in the test automation recipe. So we cannot do UI test automation without Selenium. Ever since Selenium has evolved, there are so many other libraries that were built on top of Selenium. Like, for example, if you see WebDriver IO, Protractor, Selenide, ng WebDriver, Fluent Selenium, and there are so many other things. Each of these libraries are designed to solve a very particular problem in UI test automation. So Selenium, so if we have Selenium, why should we use Selenide? So if you have Selenium, Selenium is not a test automation library. It's a browser automation library. So we definitely need something specific for the test automation library, which will make the life of an automation engineer easy. So that's the benefit of Selenide. So in order to evaluate any tool, first what I will do is whether it will satisfy my requirements for the test automation or not. So what are the business needs for UI automation? Basic needs for UI automation. So first of all, it has to run in multiple operating systems. It has to support multiple browsers. And whether I'm running my tests in Sauce Labs or any other remote host, it should support. And it should support all the build tools like Maven, Gradle, or any Jenkins for nightly regressions and all. And Selenide supports everything. Because it is built on top of Selenium, you can do whatever that you can do it in Selenium with Selenide. And on top of it, the extra benefit that we are getting is it is designed for test automation. So let's try to understand what benefits are we going to get with Selenide. So this is a little buggy code, messy code I would call. But this slide will definitely give you an understanding of what is the boilerplate code that I'm writing here. So this is a sample of Selenium code. So first I'm instantiating a Gecko driver. I'm planning to execute it in Firefox. And then I'm calling a URL, which is sourceCon, and I'm doing a implicit wait. And then I'm trying to find a particular element on a web page, and then I'm trying to find another particular element, and then I'm doing thread.sleeps, and I'm doing some fluent wait. And again, I have written a utility called isElementPresentBy, where I'm testing whether element is there on the web page or not. And I'm using a JUnit assert to verify whether that element is present or not. So indirectly, I'm saying return true if the element is present, and return false if the element is not there. So this is exactly what I'm trying to do. So all this messy code might not happen in one particular Java class or one particular test case, but eventually, if your project goes bigger and bigger, at random places you might end up, if you are not following best practices, you might end up having the buggy code like this. So if you are using Selenide, this is how it's going to look like. For me, this looks very clean, and it's easy to maintain, easy to read. So it clearly says the agenda. So I'm verifying the visibility of a particular test. I'm opening sourceCon, and I'm identifying element with about by text. And then I'm verifying at the very end that condition should be visible. It's that clean. Yeah, so let's go back. So this is how a Selenide test code would look like. Open, so you don't need to worry about creating an instance of your driver or creating desired capabilities. Under the hood, Selenide takes care of everything. So the question might be, so I'm saying open, and which browser it will be open, right? So by default, it opens in Chrome, which is the faster, more reliable browser compared to all the other browsers. And if you want to change it, you can simply change it in the configuration properties like this. So you can add this configuration.browser, and if you want to save the screenshots by a single attribute, you can add these capabilities. And it's not necessary that you can put everything in this code. For example, if your test needs to be run in different browsers at the same time, you can configure those jobs and add these parameters from the command line. It will handle all the things for you. You don't need to put anything in the code. Yeah, BDD with Selenide. Now I don't need to instantiate any drivers, and I don't need to write any repeated code. I don't need to write any wait conditions and all. By default, every element that I'm finding in Selenide waits for 4 seconds, and it is a conditional wait that comes within the framework, that comes within the library. And it is a conditional wait. And if I have to change it, again, I can change it in the configuration class. So that helps us a lot, actually. So when we are running tests in a remote browser, we have to maintain different waits compared to when we run it in our local. So having this at a centralized location, it was very easy to make that change. So BDD with Selenide, writing test code that matters is what we achieved. So let's talk a little bit about what are the additional Selenide benefits that we are going to achieve. So the code simply looks like this, and it has concise API. As we have seen, the API is very easy, and it reduces the need of writing a lot of boilerplate code and solves the problem of timeout issues because it has inbuilt inbuilt timing related stuff, so it solves a lot of timing problems. And no more stale exceptions. So if the element goes stale in Selenium, so it quickly throws stale exceptions, but with Selenide, you can forget about all these stale exceptions. And the very big advantage of using Selenide is it has advanced UI locators. So many additional UI locators are there, which supports advanced JavaScript libraries. We'll discuss in the coming slides. This is just an overview of what it benefits. And it has inbuilt validation mechanism. So you don't need to write any asserts, and you don't need to indirectly validate whether that works or not. So if you see the third line in my code, it says should be, and there is a condition class, and then I'm saying visible. So the inbuilt validation mechanism is a very good thing that I like in Selenide. And inbuilt evidence capturing mechanism. So if something goes wrong, it automatically captures a screenshot and it automatically captures the page source as well, and it saves everything at a particular location. Again, if you want to change that location, you can easily customize it. And it reduces the need of adding a lot of third-party libraries. We'll discuss in the coming slides. So let's talk a little bit about additional selectors. So in Selenium, we all know that we have name, ID, XPath, CSS, and there are so many. But your locator strategy should always be ID. That is the best one, but we cannot guarantee that we can find an ID. If the development team is with us in the same sprint or in the same location, we can make sure that every element should have an ID. But if you are working with a COTS product like Salesforce or some other products, we cannot guarantee that we're going to get particular IDs. So in that cases, people are ending up with writing XPaths, and quickly it goes like a nightmare. So for example, on this SOSCON website, I'm planning to look for a text called agenda. And once the about is clicked, then there is a selector called by text. So this straightforward text is not there in, this locator is not there in Selenium. At least there is an indirect way that you can identify it with by using XPath. And there is a similar selector called with text. So if finding an element and if you are not sure that the element will be there, you can add a pattern, a regex pattern, and then if that regex pattern has a similar attribute in it, you can identify it with text. And there are a bunch of other selectors, and the matter of time, I'm going to quickly wrap this up. And parent and child selectors, and these are also very important when you're dealing with tabular data. So when you're dealing with the tabular data, it is very hard to add IDs for all of them because the data might be dynamic. So ID is not a good candidate over there. Selenide has additional selectors, like you can select parent, the closest child, and the closest model. And you can identify different selectors like CSS selectors, and there are so many other good ways to do it. So this is much more helpful when you're dealing with the data that is in the tabular format. And jQuery Sizzle Selectors. So these are not at all straightforward. So it has its own attributes. jQuery, Angular, and everything will have its own attributes. So in Selenium, there is no straightforward way again. We'll end up writing XPaths. In Selenide, you can do something like this. So if there is an input attribute in the jQuery selector, you can select an attribute based on that particular item. So I'm saying, if I say ... and input, it will identify that element for me. You can quickly identify, and then you can match it with the collection conditions and other things. So these are a couple of other examples on that. Similar thing with Angular. So if people are dealing with Angular, you might have been got this. So Angular attributes are a little different. The locators are a little different in Angular. So each one will have, it starts with ng, if, ng button, ng click. So the attributes look something like this. So here I have a customer login, and simply I can say customer login based on the text and click. You can select it like how I have shown the jQuery one, but in this example, I've used ng WebDriver, which is developed by ThoughtWorks. So I have integrated ng WebDriver with Selenide. So this shows Selenide's additional capability where you can integrate multiple other libraries and have those capabilities as well with Selenide. So by Angular, whenever you say by Angular and CSS text, you can identify that third one that you are seeing, that ng repeater, ng models. You can quickly identify the elements like this. And custom matchers. So you can create your own matcher in Selenide. For example, if your project team, UI developer, UI team are writing they are following a particular pattern for writing custom CSS, then you can follow the same pattern and write a matcher for that. So this is an example of writing your own custom matcher. You have to override apply method, and you will get the custom matcher ready. You can follow this consistently throughout your project. This will add more stability to your tests. So that's all about matchers. And let's have a look at the radio buttons, and there are some, so in the coming slides, there'll be list box, pop-ups, alerts, and all. I have added a couple of snippets to show the coding differences between these two. So if you are having a radio buttons, and if you have 10 or 20 lists in them in Selenium, you have to basically identify, get everything, put them in a list, and use some iterator to iterate it, and then get the value, put it in a class, and then identify that element. So there is a lot boilerplate code that you have to write if you're using Selenium. So in Selenide, you can simply say select radio, and you can simply by name or by text of that radio button, you can select it. Same thing with list box. You can select it by the list box. Alert box. So you can, based on the text on the alert box, you can identify. So confirm and dismiss are the two things, okay or not okay kind of things that you can easily do. And so many other functions. So these are all related to double click, mouse click, drag and drop, mouse related actions. Another good thing about Selenide is you don't need to remember anything. IDE drives you the whole thing. So whenever you find an element and then you put a dot, IDE drives all the methods. You don't need to worry about remembering everything. You can start coding. Collections. This is one of the best capability of Selenide. So when I say $, that it actually takes, identifies an element. When I say $2, then that returns a collection. And collection, it has a different set of validations, and yeah, so, and it comes with a collection condition. That is one of the library that is there in Selenide. And for example, in the third thing that we are using, we are identifying this to see if the size is greater than 3. So if you have to write Java code for this, you have to first identify the element, and then you have to get all the contents, put them in a list, and iterate the list, put them in an object, and verify whether that particular list size is 3 or not. So there are some other indirect ways that you have to do if you are dealing with the regular code, classic way. And in Selenide, you can do simply like this. This is especially beneficial if you have to do negative testing. So if you have, if there is a list box and you have to identify whether a particular text is there or not in the list box, that might be easy. But if you have to verify whether the particular item should not be there, then even if the list is bigger, like hundreds and hundreds, you have to loop through and you have to consistently look into that, which will drastically lag the performance of your test execution. So by using methods like this, you can quickly identify things. Some other examples on Selenide Collections. Okay, and this is a monster. So file downloads. So if you have to download a file with Selenium, you have to set certain profiles, like where should the file be downloaded, where should it be, and what location, what permissions does it has, and what size it should be. Certain profiles that you need to set for a browser, and it's for each browser. If you have to support multiple browsers, you have to write a lot of code for each browsers. And if you have to verify that file with a different file, in Java, again, you have to write a lot of code. You should be very good, like a code Bruce Lee, to write this, like buffer reader. You should know about buffer reader, and you should know about different line mechanisms, and you should write the proper asserts, and so many other things. So in Selenide, you simply do it like this. Identify the element and call it download. And there are so many other functions that are related to the files. You can simply call the compare to method and pass the expected or actual file. And there are so many other file operations. You can get the parent file, and you can verify whether what executable permissions does my file has. And if you have to create a new file at a particular location with one single line of code, that you can achieve this. Similar thing with file uploads. Yeah, identify the element and upload file. Page object design pattern. This is a very important design pattern that we have to use it in Selenium. The basic idea behind page objects is basically get all the elements which are repeated in a particular page, abstract it in a different page, and write utility methods on top of it. So, and then in order to make this happen, we have to create these particular driver instances on all the particular classes, and we have to make sure that we are writing page factory to follow the right standards and everything. So in Selenide, you can do page objects, but in an easier way. You don't need to worry about creating driver instances. Selenide under the hood, it handles all of it. So you can just identify the element and write the particular search criteria or whatever the condition should be, and in your actual class, you can call that method. It's that simple. You don't need to build a whole architecture or a design to happen this particular encapsulation. And if you want to write classic page objects like you have to do it with Selenium, that is also possible, and this is how you do it. And this example shows that inbuilt evidence capturing mechanism. So this is one of the Java code. Let me, so if something fails, Selenide automatically captures the screenshot and also the page source. And it saves at a particular location, and the error report is very meaningful. So in Selenium, it simply says no such element exception. But here it shows the list is, you're expecting 9, but you're getting 10 or whatever it is, and it shows the collection, what are failed in that particular things. If you see, let me show the error report. Simply going down, I have 3 more minutes, okay. Okay, so yeah, expected is 10 and the actual is 9. And it also shows where exactly the thing happened and where exactly the screenshot is saved. For the sake of time, I quickly move to the next slide. Okay, so what is the return on investment that I'm getting out of this following BDD or Selenide? So this is about BDD. So years ago when we started adopting these practices, so we were like an ice cream cone at the very bottom, like a traditional, which it might be a good dessert, but our company doesn't like it. They want to be lean. So by following BDD practice, we were able to invert our ice cream cone. We drained all the ice cream, and now we are lean. So the down you go to the pyramid, the tests will be much more faster and much more reliable, much more cheaper. And the up you go the pyramid, it will be expensive and flaky. So by following patterns like TDD and BDD, you can invert your test pyramid. And not only that, if you're following BDD, you can have the documentation. The initial slide that we have seen on how the features are converted into scenarios, that acts as a living documentation for your project. So if something in the requirement changes, the underlying test needs to be changed. So it's that tightly packed, which is much more business focused. And the return on investment on Selenide. So the coding effort, we saw 40% reduction, and this 40% is the minimum scale. So this completely depends on the application under test. So if the application under test has more validations, it could go up to 60% as well. But we have, the minimum scale is 40%. And increase in the script reliability, we were able to increase the reliability to 30%. Because of the custom matchers or whatever additional selectors that it has inbuilt weighting mechanism and all other good features. And the 40% reduction in code, you can generate a lot of metrics on top of it. You're reducing the maintainability time, and you're reducing coding time, and there are so many other metrics that you can generate on top of that 40. So, and there are some couple of good resources on Selenide. Selenide website itself has a lot of good examples, and they have GitHub repo where you can find a lot of coding examples, and there is a cheat sheet where you can find all the commands and other stuff. Okay, BDD with Selenide is all about writing software that not only works but matters. That's all. Thank you.